Concrete strength in construction plays an important role, and it gives us how we shall be able to obtain the concrete strength on the site. At this stage, we involve the use of the mixture design. So in this video, we shall navigate through on how to come out with the concrete mixture design of the materials we have at site. Hello friends, welcome back to this channel. It's a great day here at IngaviCAD Engineering Solutions, and I'm here to talk about the concrete strengths. From very far, people have been asking how can I come with a mixture design. But for me here, I'm going to explain through until we get the values we need here on the cement, water, fine aggregates, and the coarse aggregates. So stick with me as we go through this. So in this video, we shall start with the job title. No wasting time. Job title, what shall we be doing? Let's say we need to make a mixture design for columns, for beams. How can we do it? The title, I will say we are making a concrete design for columns. Yes, columns by IngaviCAD. So that is it, and then we shall come on the characteristic strengths. This one is already specified. Let's say we need C25, C30, let's say at 28 days. We shall specify we need a C30 at 28 days. You can put in the values you need. If you need it, you can be able to put the values. So the proportion defective, we always get it from page 9 here. Page 9. Let me come to page 9 and see. We get the value of K. Let's say if we want to be sure by 1%, if our error should be within 1%, we should use the defective as 2.33. If we need our error to be within 2.5%, 5%, or 10%, we use any of the values corresponding to this side. So my percentage defective will be 2.5%. I need an error about 2.5%, and I will use a detective of 1.96. So when here the percentage defective, I will use 2.5%. Then the standard deviation is obtained in figure 3 on the page here. The standard deviation, what strengths do we need? It is 30 at how many? At what? 28 days. We shall draw a line, a vertical line. We shall draw a vertical line from here above. Mine is not vertical, but we shall draw a vertical line, and we shall check for this A line for less than 20 results. We have made less than 20 results. We have obtained less than 20 results. So we shall come here for the 20 results, and we get where this line corresponds with this value. So the defective, we shall use 8 here, and we shall go back here. And we use the standard deviation of 8. I think you will be getting where I get these values. So if there is data, we can use any which is here, but for us, we are getting it from the table figure 3. So in calculation of the margin, we shall use the K we obtained from the other side, which was 1.96. We multiply it by the margin, which is 8, and we shall get a value here. Calculator, we need a value here. It is 1.96 times 8, which gives us 15.68. 15.68. Yeah. So this is the margin we shall use. So the target mean strength, we shall get the characteristic strength, which is 30. We add our margin, which is the value we got here, which is 15.68. 15.68, and what we shall get plus 30, we shall get 45.68. 45.68 as our design strength. Yeah. So if we want, let's say, a strength of 30, we shall not design that one of 30, but we shall design that one, the design one, which is the target mean strength. We shall design needing 45.68, yeah, not 30. And these errors may happen, but we shall have designed at the more, we shall have designed more to obtain the 30. So we can be sure that we shall be able to get the results. Yeah. So the next step is to look at the cement strength class. Is it a 42.5? Is it a 52.5? Anywhere we need, we shall circle where we need. So for us, we shall use a 42.5. Yeah, a 42.5. Let me just circle it. Shall need a 42.5. Yeah. So what type of aggregate shall we be using? For the coarse aggregates, we shall be using crushed. Yes, we shall be using crushed. And the fine aggregates, we shall be using the uncrushed. Yeah. So after getting that, after marking these ones, we shall have to come and check for the free water cement ratio. Yeah. So for the free water cement ratio, we shall come to our page 19, which is here. Our page 19, which is here. Let me first reduce score. In order to get here, we shall look for the compressive strings we need, the one we specified. As you can check here, we specified a 45 for not this one. We shall come to this page here for the aggregates. Yeah, we check the cement strengths we need, which is 42.5. Come here, we look for the type of crushed aggregates, type of coarse aggregates. In this case, we shall need the crushed aggregates. Yeah, we move in this line. And what strengths do we need after how many days? It is after 28 days. It's here. So we shall circle the 49. The 49 value is what we shall come and look at this starting line. We look for the 49, and the 49 corresponds to a value which is somewhere like here, somewhere like there. And if it doesn't correspond to any of these curved lines, we shall have to plot our line from here up to going up to this side. So we need to plot our line. So we start from here. We plot our line. Let's say it's going that way. And here it's also going. Me first erase this one. And here it's going from here, going up this way. Yeah, we have to make sure that it is a smooth curve, not this one I have drawn, but let it be a smooth curve meeting at 49, which is the value here. 49. which is a value. This is 49. I'm writing this such that we don't be confused. Put here a value which is 49. The one we obtained from here, using the crushed aggregates and the cement type, we got a value of 49, and it's what we are using here. And we are going to obtain our cement ratio. So after getting that, the 49, we shall come on our strengths here, which is 45.68. We look for it in this diagram, 45.68. Draw 45.68, which is somewhere like here, 45.68, 45.68, and we shall draw a line which is horizontal up to this line we have drawn. And after we have drawn that horizontal line, we slope it down here. We slope it down here to get a value here, which is approximately, if this is 0.5, this one can be 0.54, 0.55 here. So our value here, we shall take 0.54, 0.54, as our free water content. So we come to our design, we take 0.54, 0.54 as our value there. Then the maximum, the specified, can be got from codes, but we shall use 0.55 as our maximum. So use the lower value. If this one is high, the lower value, we check in these values which is higher, and we use a lower value which is 0.54, 0.54. So, and this one will be our free stroke cement ratio. We shall use a value which is 0.54. After we have done that, we shall come and specify the slump test. Do we need 30 to 60? Do we need 10 to 30? For us, we shall use 30 to 60. From the slump, as I told you, we shall be looking at these ones. We need to first look for how to do the slump test. But we shall need a slump of, let's say, 30 to 60 millimeters, or we can also use the verb time. It depends on the slump or what we shall use. So the maximum aggregate size, it is specified, and let's say we shall use a maximum of 20 millimeters. We can have a maximum of, let's say, 40, 10. We can specify there. Then the free water content, we shall have to determine it from a table. A free water content, we shall have to determine it from a table which is here, a value here. A table, it is this table which is on page 20, page 18, and you use this table. We need a maximum size of aggregates to be 20, and the maximum size of the aggregates to be 20, and the type of aggregate. But we need the crushed. We need the crushed, which is here. We shall use this table in this value to get the free water content. How shall we do? It will be a third. It will be 2/3 of the uncrushed, 2/3 of the uncrushed, using this, 2 out of 3 of uncrushed, which is this, and a third of the crushed. Yeah. So what we shall do will be 2/3. 2/3. I think I should write it here. 2/3, 2/3 times the uncrushed, which is 180, then plus a third of the uncrushed. I think it is the crushed, which is 210. Of the values I obtained from where? From here. I said it is 2/3 of the uncrushed times a third of the crushed. Yeah, since we had the maximum size of the aggregates, it's where we obtain. It is where we obtain this, and the value we obtain here, it will be 190. 190 as our free water content. Yeah. So for the cement content, for the cement content, I'm sorry for being late, but we have to do this. For the cement content here, we shall get the water content we got, which is 190. This one is supposed to be a division sign, divided by the water content we used, which is 0.54. 0.54. As you can see, this one, the value here, we obtain it from here. Yeah, and this value here, we obtain from this value here. And this one is supposed to be a division sign. So when we divide here, we shall get a value which is 3. If I get 180, calculator, 190 divided by 0.54, I get 351.8. 350. Yeah, which is 350. 351 point some values, which is 85. Yeah, we shall get that value. Then the maximum cement water content, the maximum is 500. Maximum is 500. The minimum is 330. From the codes using, let's say, Euro code, it can be this. Then we have a value. Use 3.1, which is here, when the value is less than 3.2. Yes, we have to use this one. If it is better than that, we opt for this. Then another one, use 3.3 if it is greater than 3.1. Use 3.3 if it is greater than 3.1. If we had a value here, let's say a value, let's say 320, we would use 3.30. So our value is greater than this. Use 3.3 if it is greater than 3.1. Yeah, if we had a value, let's say 320 here, we could not opt for this, but we have to opt for this value. But our value is within the ranges, and so we shall use the value we have, which is 351.85. Yeah, 351.85. I obtain this value from here. Yeah, let me put for this such that we can understand where we obtain the values. Yeah, so the modified free water to cement ratio is obtained by getting this one, the free water content, which is 190, which is 190 to the 351.85. But in our ratios, we can use 1, 2 space. I can get this one divided by this. We divide it by equals, divide it by 190. What do I get? I get 1.8. So this one is approximately 2. So I put 2. So it means that if we have one part of the water, if we have one part of the cement, I think we shall, if we have one part of the water, we shall be using this one of the cement. Yeah, so that's what it means. This one is of cement, this one is of water. Yeah, we proceed. Go to the relative density of the aggregates. This one is always obtained from the density of aggregates we used, and in this case we shall use density of 2.5 or 2.4. It is assumed or known because we do tests on the aggregates and determine the relative density, and then we shall have the concrete density. Look for the concrete density. It is obtained from figure 5, which is concrete density. Obtained it from where? From page 20. This one is page 16. Page 20. Page 22. Where is our page 20? 17, 18, 19, 20. It is not shown here, but it's here. Page 22. Yeah, it's a mistake, but it is page 22, where we have the weight density and have the values of the corresponding density of the aggregates. It is assumed for uncrushed, we assume if it is a value, we use 2.6. If it is this, we have 2.7 in case we don't have the relative density. But for us, we are using a density of 2.4. So we shall move in this line. Then we look for the free water content. Our free water content was 190, which is the middle of this. We draw a line moving up, and also draw a horizontal line. My horizontal lines. Let me remove this. Draw a horizontal line up to this point, and estimate the value, which is since this one is 2200 and this one is 2300, I can say this one is, let's say, 2220. Yeah, estimate this to be 2220 as our density of the already finished concrete. So we shall come here on our mixed design and specify, which is this one, 2220 as our density of the concrete. Yeah, so we have the total aggregate content. So this one is for water, the 190 is for water. So if we get the value of the finished minus that one of the water, which is 190, we can be able to get the proportion of the aggregates remaining. Let's say it is 2220 minus 190. We get 2030. we get 2030 as our value here in the aggregates. Then after getting that, we shall come grading of the fine aggregates. Grading of fine aggregates. We have to look for the percentage passing through the 600 millimeter sieve. Yeah, this one you have to have made the test and we specify the value. So me, I've decided to use passing through the 600 millimeter sieve. Let it to be 60%. Yeah, let it be 60%. Then the proportion of the fine aggregates. How will I determine this? The proportion of the fine aggregates, I will count our tables here. We have the slump test. We shall specify from this. We had specified our slump to be within this range. If it was within this range, we would have used these boxes. But according to our slump, we are using this table as our control point. Yeah. So this one gives us the proportion of the fine aggregates we need. Then here down we have the free water cement ratio, which we determined as our value, which was 0.54, which we obtained from the other graph. So we estimate the value here, 0.54. We draw a vertical line. Your line should be vertical. You should use a ruler, not like mine. And then here we shall also look for the target strength of the concrete. Our target strength was 45.68. So we have to come and look for it here. Our target strength was 45.58. So we have to look for it here. Estimate a value here. Is it? No. We don't use the target strength, but we use the percentage passing, the value we obtained from where? We use a value we obtained, the value we obtained here on the percentage passing through the 600 millimeter sieve. We shall use the percentage passing through the 600 millimeter percentage sieve, but our value was 60. So we shall drop a line, a horizontal line to this point. Yeah. So the value here gives us from here a horizontal line, shouldn't be confused, and this one corresponds to 40. Yeah. We obtain the free water content from the above procedures. Drop it on our graph here by looking at the slump test we obtained. Then the 60% will be the percentage passing through the 600 millimeter sieve, micrometer sieve. Then we draw a horizontal line. Yeah. Use this one, the 60 line, and the vertical line passing through the water content, and we shall be able to get the proportion of the fine aggregates. Yeah, I think there we are okay. Come to this point, and we found that it was 40%. Yeah, it was 40% from our other table. So what will be the percentage of the fine aggregate? It will be 40% times this concrete strength. So it will be the 40% times the 40% times the 2030. This is percent. It will be percent. Yeah, times the 2030. What do we get? AC 0.4 times 230. What we get, it is the 812 is what we shall put here. For this way, specify two significant figures or decimal places, but what we write here, it should be a multiple of 5. So instead of using that 812, we shall use 800. Yeah, 800. Then what we shall use on the cost aggregates? We shall use the 2030 minus the value of the fine aggregates, which is 800. What do we get? What do we get? It is AC 2300, 2030 minus the 800. We get 1230. 1230. Yeah. Then after we have done that, we now qualify. We have the value of the water. We have the value of the cement. We have the value of the cost aggregates. We have the value of the fine aggregates. Now we can be able to determine the batching. Yeah, the batching. This one is per meter cubed. Per meter cubed nearest to the 5 kilograms. As how I said, it should be a multiple of 5. Yeah, in our concrete design, per meter cubed, the cement in the kilograms, we have the water, the fine aggregates will be 800. The cost aggregates, we have to maybe specify here, but the total will be 1230. One can specify that my aggregates should have a value of 10 millimeters, can have a value of 20 millimeters, can have a value of 400 millimeters, but that will be the overall. The value of the water in kilograms, the value of the water in kilograms will be the 190 we looked for, the 190, and also the cement will be 380 kilograms per meter cubed. As you can see, we have been calculating in per meter cubed, so we shall have to estimate the value here in meters cubed per meter cubed. If we have a trial mix, let's say of this one was 1 meter cubed. What if we need per 10 meter cubed? What we shall do, we shall multiply by this. This one becomes 3,800. This one becomes 1,900. This one becomes 8,000. And this one becomes 1,2,3,0,0. Yeah. Depending on the batch volumes you need. One can say I need a 0.5 meter cubed. You multiply, you get the values here. One can get a value of what you multiply, you get the value here. Yeah. So that marks the end of our mixture design from the beginning up the top. If you want a PDF of this, you will be able to ask me in the comment section. I will be able to provide, or you can check in my description and get the email. Send me an email. I will be able to provide you with this PDF, and you can be able to do your own concrete mixture design very well, simple, and can help you to design your concrete, not to be able to be fraud, not guessing, but to have done it on site. Yeah. So thank you very much for watching. If you are new on this channel, please consider subscribing to my channel, and always make sure that you hit the notification bell such that you can never miss out on any upload. I remain Gav. I'm from GravCAD Engineering Solution. Thank you very much for watching. Bye. Let me see you in our next video.